turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the Naked Scientist podcast. This is the programme that brings you the biggest breakthroughs and also talks to the major movers and shakers in the worlds of science, technology and medicine. I'm Chris Smith, and coming up, Russia stands accused of murdering opposition leader Alexei Navalny with dart frog poison. But how might it have killed him? Also, the first comprehensive study of cancer in domestic cats and what this reveals about our understanding of the human disease. And the former US President Barack Obama sparks controversy with his views on UFOs. We get the alien perspective. In August 2020, the Russian opposition leader Alexei Navalny survived poisoning with a nerve agent called Novichok, a substance first developed in the Soviet Union. Subsequently incarcerated in a Siberian penal colony, though, he died 4 years later at the age of just 47 after collapsing suddenly. The Kremlin claimed his death was from natural causes, but Navalny's supporters have long suspected foul play. The case echoes earlier incidents. In 2006, former spy Alexander Litvinenko was killed with radioactive polonium in London. In 2018, ex-intelligence officer Sergei Skripal and his daughter were poisoned with Novichok in Salisbury, and decades before that, in 1978, the Bulgarian dissident Georgy Malkov was murdered on Waterloo Bridge with a pellet containing ricin. Now, the UK and its allies claim that Navalny was poisoned with a toxin first identified in poisoned dart frogs. But how do we know that, and why would the Russians use that? Alistair Hay is Emeritus Professor of Environmental Toxicology at the University of Leeds.
What has emerged is that 5 governments in Europe, including the UK and Germany, have claimed that a toxin, which is present in nature on frogs that you find in South America, the dart frog, this toxin was used to poison and kill Alexei Navalny when he was in prison in Siberia in Russia. They make the claim because they were able to analyze samples which were smuggled out of Russia and tested in laboratories, presumably in the UK and Germany, but we don't know for certain, and they revealed the presence of this frog toxin.
What actually is the toxin?
The toxin is called epibetadine, and it is produced in the frogs, and it appears that it is produced based on what they eat, and it's secreted on the skin as a deterrent for predators. Interestingly enough, this toxin is not made in the frogs when they're held in captivity. So suggesting something in the diet is necessary for the production of this toxin.
Because the indigenous peoples it's Ecuador, isn't it, that those frogs come from, used to rub the darts that they blew to hunt on the skins of these frogs. That's why they're called dart frogs, isn't it?
Yes, many different toxins from different species are used or have been used in the past by local communities across South America to, if you like, cripple whatever is shot. So this is one of those toxins that, if you like, increases the effectiveness of an arrow or a spear.
What's its mechanism of action in the body? Once it gets in, how does it disable?
What you have in parts of the nervous system is a sort of gate. It's called a nicotinic receptor. Now, this gate controls a number of other gates, if you like. But with all gates, there is a lock and key system. And with the right lock, you unlock the gate. And the normal key to unlock the gate is called acetylcholine. But with acetylcholine, you have a mechanism for, if you like, unlocking that gate again, and that's an enzyme, and that removes acetylcholine from the gate. Now, there are mimics, if you like, other alternative keys that will also bind to this lock, and epibetadine is one of them. But unfortunately, with epibetadine, it is not removed out of the lock. And so the system, the gate doesn't open and close as it should do to transmit messages to muscles. And that the messages to the muscles are contract and relax. So the key goes in, the muscle contracts, the key is removed, the muscle relaxes. And that enables our muscles to work, particularly those that control breathing, allowing the chest wall to expand and relax. So when you have something like epibetadine in the lock, there isn't an efficient way of taking it out. So the system stays locked permanently. Muscles are paralyzed. And of course, that means your chest wall doesn't move and you can't breathe. So people, they suffocate.
Would the Russians, if what is being alleged is true and correct, would they have had to have gone to Ecuador to get dart frogs then to get this? Or can we make this stuff artificially? We got the insight from the frog, but now a clever chemist can make it.
A good organic chemist would be able to make this without any difficulty. The structure is known, has been published for decades, so a chemist would make it, unless, of course, they wanted a holiday to Ecuador, to hunt for some dart frogs.
So the likelihood is this would have been a synthetic form of what the frogs have that would have
Absolutely.
then been deployed against Navalny.
Absolutely, yes. And it would have been something that Russian scientists had looked at for some time, would be in their library or their armory, so to speak, so they would know how this thing works.
It's not the first time someone tried to poison this gentleman. They had a go previously. He was taken ill on an aircraft, wasn't he, and ended up in Germany in intensive care. That was allegedly Novichok, another Soviet-era toxin.
Port and Down or chemical defense establishment have state-of-the-art equipment, something much, much more sophisticated than you would find in the average university laboratory. And that enables them to, if you like, be able to identify substances which are present in much smaller quantities than the average academic laboratory or hospital laboratory would be able to do.
Now, I appreciate you are a scientist, you are not a policymaker, but with your speculative hat on, why would Russia go to these lengths? There must be easier ways to dispense with someone you don't want. Seems so extreme to use a frog toxin.
I incline to the view that Russia would probably want to use something that they hoped would not be identified. They would want Mr. Navalny out of the picture because he's been a constant thorn in the side of the Putin regime, Putin government. And I think using something as sophisticated as this, they would hope that it might not be identified. The previous chemical used against him, as you said, was a Novichok. It's a nerve agent. With Novichoks, there are antidotes to them, which, if applied early, can save somebody's life. And that's probably what happened when Mr. Navalny was initially poisoned. He collapsed. He was on an aircraft that made an emergency landing. And doctors in Russia treated him initially before he was taken to Germany for final treatment. And he was in intensive care in Germany for several weeks. But the doctors in Russia probably saved his life using one antidote.
And is there an antidote to epibetadine like there is for Novichok?
No, not that I'm aware of.
Alistair Hay from the University of Leeds. Cancer is one of the most common causes of death in household pets. And in dogs, this has been the subject of significant scrutiny over many years. But much less was known about cancer in cats. Until now, that is, because an international team has conducted the first large-scale genetic study of domestic cat cancers. And not only will this new study improve our understanding of how our cat friends succumb to cancer, it will also shed light on the disease in us too. The Wellcome Sanger Institute's Louise van der Weyden conducted the study, and I began by asking her what first sparked her interest in cat cancers.
Well, it comes from a lifelong love of animals. Having pets all my life, it's really hard to lose them. And being Australian, I got to say, I love an underdog, right? So there's been so much sequencing, genetic code of tumours that arise in dogs, but virtually nothing had been looked at in cats. And it just seemed hugely unfair.
How did you go about it then?
We collected samples from vets where they'd taken tissues from the cats that had developed cancer to try and, tell the patient or the patient's owner what type of cancer it was. And then we looked at basically the genetic code that was in these tumours and asked ourselves, how does this differ from the genetic code that is in healthy tissue? So what changes have been made? What mutations were going on that had led this cat to develop cancer?
Were there consistent patterns there? Do you see the same changes that tend to crop up in the same sorts of tumours in these cats?
There were some genetic codes that were common across the tumour types. For example, there's a particular gene known as TP53, which is a really, really important gene. It's called the guardian, and it's very important to help protect the body from developing tumours. And that gene was frequently had changes in its DNA. But then sometimes there were changes in code that were very specific to a particular tumour type. So it's a mixture of both.
And if we compare that with the sorts of tumours that dogs get and the sorts of tumours that humans get, do you see the same sorts of genes changing, or are cats a bit special?
Well, as a dog lover, I can say cats are always a bit special. But sometimes in some particular tumour types, there were definite similarities in the genes that were mutated in cats and dogs and humans. And other types, we found some genes were altered more or less in a cat than they were in, say, the human. It was quite different per tumour type. But overall, the similarity between cats and human was actually strikingly similar.
Does this mean then that we can almost use the cat as a guide to where tumours might stem from in humans? So if you find particular genes in cats that are linked to certain tumour processes, we can go hunting in us to see if we've got the same problem.
Yeah, definitely. What we're proposing is part of the one medicine concept, where people are saying, look, let's let veterinary medicine and human medicine progress together rather than keeping them separate. So what we learn in one species can help the other. So if we find, particular mutations that are commonly occurring in the cat, and they also commonly occur in human tumours, we now have a viable model that we can use perhaps for drug treatments or trialing drug treatments, or helping us to understand how this tumour has arisen in cats and then help us understand the same thing in humans.
What does the outcome of this study look like then? Have you basically got a list of genes that are linked to certain cancers in cats? Or is it more of a kind of roadmap for, yes, we've got some genes linked to cancers in cats, but also this is how we can link genes to cancers in cats and potentially humans in the future? What does the outcome look like, and how can we apply it?
It's a bit of both, really. It's no longer the cat genetics understanding the alterations in the code that led to the cat developing cancer. That's no longer a black box. We can understand now. And if we can understand what the alterations in the genetic code are, we can then have the ability to develop drugs against that, because that's how targeted therapy works in treatment of human cancers. You develop a drug against a particular change in the genetic code so that you're just selectively targeting those cancer cells. So now that we understand that, it gives us the opportunity to, try and develop drugs and more therapy for cats as well. But then the more we understand about cats and the more similar we find out to humans, then it's a two-way street. It'll help us understand the biology of cancer in humans more and potentially develop similar treatments there as well, because if something's successful in the cat against a particular alteration, there's no reason to believe it won't then be successful in humans as well.
Louise van der Weyden, she just published that analysis in the journal Science.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is the Naked Scientist podcast with me, Chris Smith. Still to come, why Barack Obama's comments on aliens have prodded the UFO conspiracy theorist Hornet's Nest. But first, as stars approach the ends of their lives and run out of fuel, their core becomes unstable and it eventually collapses. Now, if the star is large enough, this, we thought, triggers an explosion called a supernova. And when this happens, the outer layers of the star are blown to smithereens, it gets very bright and hot, and then the core implodes to form either a black hole in big stars or a neutron star in slightly smaller stars. Theory does allow, though, that the supernova event in some stars might stall through a lack of momentum, leading to the star skipping the supernova event entirely and immediately collapsing into a black hole. But it was just that, a theory. Now, Kishelay Day at Columbia University, gazing at a very bright star in the nearby Andromeda galaxy, has spotted this happening for the first time.
What we see is evidence of a star that used to be alive in our nearest galaxies, called the Andromeda galaxy. It's about 2.5 million light years away. And what we saw was evidence of a star that has been around for the last 4 decades, as far as we can tell. And around 2015 or so, it started to disappear in the light that it emitted. And so much so that in the next 5 years, by 2020, the star that was clearly there for many decades essentially disappeared into darkness. And what we can tell from our observations is that the star must have essentially died in that time period. And as it died, all the light that it was producing disappeared, and we can no longer detect it today.
And the critical question then must be, well, how big was that star to start with? So how can you get at that, and what's the answer?
Yeah, so the thing to keep in mind is that stars, even the sun, all of these stars, they produce their light because of nuclear reactions going on very close to their cores. So every star is essentially a nuclear reactor in its center. So whenever you can measure how bright a star is, you can essentially relate that back to how big the nuclear reactor must have been at its core to be able to essentially back calculate how heavy the star must have been, how much nuclear material must there be inside the star to produce the amount of light that we are seeing. So based on those calculations, what we can tell is that this star must have started off as a star that was about 13 or 14 times the mass of the sun. But by the time it underwent this death that we see from 10 years ago, the star was left behind with a mass of about 5 times the mass of the sun. And this is something that we commonly see. Even the sun loses every year some part of its own mass.
Is the unusual factor here then that, unlike what the textbooks tell us, where big stars of that sort of size, beyond that sort of size, would normally end their lives with a big explosion that would make them very bright, and you'd have seen that, this one just sort of diminished down to nothing and disappears? And so it suggests there's another endpoint for big stars which doesn't have to involve an enormous explosion, a supernova.
Exactly. So again, going back to the conventional wisdom that astronomers have had, is that stars that are more than about 10 times the mass of the sun, they must undergo these catastrophic deaths. Historically, these catastrophic deaths are marked by supernovae, and each individual supernova explosion can outshine its entire galaxy for a few weeks. But it's always also understood that some of these are probably not undergoing supernova explosions and instead collapsing inward because of gravity and turning into black holes. Except finding those individual stars disappearing is a remarkably difficult task.
You don't think that there was another star that had already turned into a black hole sitting next to it, and it somehow got close enough to just get eaten, and that's why the light disappeared?
No, that's an excellent hypothesis. This is something that's discussed quite widely, but we think you'd first have to have a black hole that's right next to it, and you'd somehow have to make it fall into a collision course into this star for it to sort of eat it directly. So I think in terms of the probabilities, I think it's unlikely that something like this happened, but you're right in that if this did happen, then it might produce a signature that looks similar to a star just disappearing into darkness.
How do you account for what you found then? If we assume that it's not eaten by a black hole or something like that, this star has genuinely, of its own volition, got to the end of its life, collapsed into its own black hole. Mm-hmm. Why did that star behave like that, whereas other stars of equivalent size do have a humongous explosion that we can see for weeks?
Yeah, no, this is really one of the most important questions in astronomy today. So far, the majority of the work in this direction has been theoretical. So what we think and what is fairly well appreciated in the field today is that at the end of the star's life, what is happening is that this nuclear reactor in the center of the star has suddenly run out of fuel. It is no longer able to hold the star against falling against its own gravity. The traditional picture is that during this process, there are these subatomic particles called neutrinos, and these neutrinos are responsible for pushing out the rest of the star against falling in because of gravity, and that essentially produces what we see as a supernova. Now, why these neutrinos are able to do it and how that mechanism plays out is a big uncertainty. But what we do know is that there are situations in which, because of somewhat randomness, in which neutrinos can interact with real gas and the way it interacts with gravity, this supernova essentially fails to explode, in which cases one might expect that they would turn into black holes. There are essentially a few different channels in which this can proceed. One is that in many cases, we have direct evidence that when a star does blow up at the end of its life and produces a supernova, it actually leaves behind these things that we call neutron stars. So neutron stars are objects that are very massive. They can be about 1.5 times the mass of the sun, but except they are all of that mass is concentrated in the size of a city like New York, maybe 15 kilometers wide. The other option is you can have a supernova explosion that also leaves behind a black hole. Or you can have the third possibility that a star doesn't explode at all and it just collapses into itself and leaves behind a black hole. And I would say that in terms of our understanding of which stars undergo which process and how common each of these processes are is pretty much up for debate right now.
Kishalay Day, and that study has just come out in Science. Barack Obama, the 44th President of the United States of America, and some say the first to talk seriously about aliens. Having said that, the former Commander-in-Chief got himself into the headlines recently because of a joke he made about the existence of UFOs. He did offer a clarification, but unsurprisingly his comments have sent conspiracy theorists into a tizzy. David Whitehouse is the author of The Alien Perspective, and he's just penned a piece on the story for the British press too, so we asked him to tell us more.
Well, Obama was taking part in a podcast, and the question was, are aliens real? He replied, yes, they are, but they're not at Area 51, and I didn't know anything about them unless there was a conspiracy not to tell the president. But of course, the febrile UFO community is always on the lookout for any chink in the government cover-up of these things. And they went into overdrive saying that this is soft disclosure, as they call it. This is part of being softened up and prepared for the big announcement that the United States has alien spacecraft, alien bodies, and that it's part of a pattern. There were rumours that President Trump was going to give a big disclosure speech in a couple of weeks. And of course, you've got Steven Spielberg's film Disclosure Day, which is about aliens and cover-ups, coming out soon. So the UFO community saw this as being something more than it was.
Has Barack Obama mentioned aliens before, or was this his first rodeo?
No, actually, he and some other presidents have mentioned aliens before. There was a reception at the White House when he was president, and he said in his speech that if he wanted to know about aliens, he'd call Shirley MacLaine because she had said she'd spotted UFOs over her ranch. And then he mentioned Area 51. And then he brought the House down by saying, I think I became the first president to publicly mention Area 51. So he's joked about it, as have other presidents, Reagan in particular, because this is the question that so many people ask presidents, are there aliens real? And the presidents have usually got their jokey answers ready to bat the question off. But Obama didn't. Obama was straight to the point, and that's what caused all the fuss.
There was a conference, though, wasn't there? And some disclosures and some analysis of what we do and don't know in the last couple of years. And is that added fuel to the fire?
Well, there have been lots of hearings and conferences about UFOs and aliens. And over the last few years, they've been organising hearings, organised by a few, I have to say it, rather wacky American politicians, bringing on people who claim they know about the cover-up and who claim they've seen aliens. but providing no evidence whatsoever. You really have to be very tough-minded and say, what is the evidence? Lots of people have stories. Stories are easy, but other than stories, you have to say, what is the evidence for this? And Obama clarified his position, saying he had no indication when he was president of anything extraterrestrial. But of course, people will not believe that. They've already started saying, well, he was forced to say that because he let the cat out of the bag.
Where do you stand on all this, though? Because my opinion, and I'm not a space scientist like you, but I am a scientist, my opinion is, do aliens exist? Absolutely, they almost certainly exist. The universe is too vast, it's too enormous, on too big a scale for the numbers not to make that theoretically possible in some form. So I think life does exist out there, but are they here? Have they rewritten the rules of physics to get here? I think absolutely not. But that's just my opinion. What do you think?
I think you're absolutely right. The universe is vast and wonderful, and it would be arrogance supreme to think we're the only form of life in the universe. But we don't know, of course. We suspect from what we understand of science that they are probably alien life forms of who knows what fabulous design and predisposition out there that one day we could perhaps contact. But the question is whether they're here is an entirely different matter, and it's a murky history of made-up stories of myth and rumour and misidentification, ultimately that has no evidence. Think about it. The idea that aliens born under the light of another star could look out at the cosmos and wonder if there are others like us and set off on fabulous voyages across the stars, arrive at planet Earth and stay just out of our reach, just show us fuzzy blobs. They mutilate cattle, they abduct people and probe them, and then they go off and crash incompetently in the desert. Is this a consistent story? Who knows what they are like? Whether they would be good or bad for us, we do not know.
Do you think that the conspiracy actually is that Spielberg's UFO film is coming out, and that perhaps this is just very conveniently timed, that these comments get us all talking, and now we're talking about that film, and that perhaps the two are connected?
Well, I don't know. I mean, the UFO community is always on the verge of a big reveal, and then it doesn't happen, and they move on to the next time it is going to happen. It has to be said that the Obamas are producing a film about a UFO encounter, Barney and Betty Hill. Of course, Spielberg read the runes several years ago of this increasing chatter about UFOs and has come up with this film. So it's part of a cultural movement feeling that comes from time to time that people make money of. And remember that when people, particularly in these days of YouTube and people getting paid for hits, people are not just telling you stories about UFOs, they're selling you stories. And this UFO phenomena has become a money-making juggernaut for some people. So, yes, it's in the air, as you say, at the moment, and that we're all talking about it. It'll die down, and then in a while, we'll all be talking about it again.
That was the science writer David Whitehouse. Well, that's it for this week. Tune in on Tuesday, though, when the director of the Johns Hopkins Malaria Research Institute, Jane Carlton, will be our guest on Titans of Science. And thank you very much in the meantime to those of you who are supporting us with donations. This is helping us to operate and continue to make world-leading content. And among your number, Russ Newton, thank you very much to you personally. We are extremely grateful. If you'd like to make a contribution to the programme to keep the show literally on the road, then do head over to nakedscientist.com/donate. Meanwhile, do please follow us on LinkedIn and Instagram for more information, and we're also very grateful to those of you leaving reviews about what you think of the programme on Spotify, Apple or wherever you get your podcasts. I'm Chris Smith, thank you for listening to us, and from all of us here at the Naked Scientist team, until next time, goodbye.